I started farming in 1982. Between 75 and 82, I paid for the farm. Thank goodness, because there were rocky times ahead in the 70s and 80s, the times when farmers sold all their equipment, everything on the farm, for pennies. We had penny auctions. And fuel crises, right? We've had all kinds of end of the world scenarios. I picked this area because I'm a geologist by training. I worked in geology for 15 years as an exploration geologist, and we're sitting on the Canadian Shield. And the unconformity with the Paleozoic is about a kilometer south of here. So I'm as far south as I can get on the Canadian Shield. So I say I'm on the Muskoka Riviera. My objective is to basically restore the fungal content of our soil. And it turns out the microbial content of our gut is tightly controlled by what the microbiome of the food we eat. So our health and the soil health intimately connected. When you start to look at soil, it's an underground world so complicated that mankind may never be able to understand it. We might not have the mental capacity to understand what goes on and to measure the metrics that we want to achieve. Because I think to produce nutritionally dense food, we have to restore the fungal content of our agricultural soils. If we don't, we maybe have 60 years left of being able to produce food. A little bit sobering. Now, I realize, and the trigger is that I was growing vegetables since '82. About in the mid-2000 teens, I was starting to have more problems. Pest problems, disease problems, weeds. The farming just wasn't as easy as it had been at the beginning. This farm was always a dairy farm, so the soil was well maintained for fertility. But I was losing, and so I said, well, I'm doing something wrong. Something is not right here. And what I concluded was it's cultivation, because an organic farmer relies, instead of on pesticides for weeds and those kind of issues, an organic farmer controls weeds with cultivation. Suzanne Simard studied the fungal world in forests, and I thought, there's got to be a fungal world in the soil also, in agricultural soils, but we were destroying it with cultivation. So about 4 years ago, I decided to just go no-till, no disturbance, hardly even with a hoe, and not the kind of hoe that you dig with a Dutch hoe that just skims along the surface of the soil. And so my objective is to basically restore the fungal content of our soil. Clean food is food with no residues of, in case of meat, antibiotics. In the case of vegetables, pesticide residues. And it goes much deeper than that, we found out. But basically, at that time, in the 70s, 80s, 90s, clean food meant organically grown. just clean of chemicals, except what is there anyway. What farmers need to produce crops is fertility, and the very basic fertility is nitrogen, phosphorus, and potassium. There's lots of potassium in clay soil. You don't need to worry about that. But nitrogen is critical, and it turns out that our atmosphere is 70 some odd percent nitrogen. And so why do we buy nitrogen from agricultural dealers, agribusiness, when it's in the air and it's free? We need to be able to pull it out of the air and put it into plant available forms, and then we have free nitrogen. And it turns out I didn't go specifically looking to improve nitrogen because I have livestock and lots of composted manure, so I'm not short of fertility on this farm. But most farmers need nitrogen and potassium and phosphorus, particularly the N and P, to grow their crops. So farmers are paying for fertility boosters that they don't need to pay for. Plants require CO2 to photosynthesize, and they turn the CO2 into labile carbon, a stable form of carbon, especially if you're growing some plants that have deep roots. They pump this carbon way down there in the soil profile at a place where it's held stable. So plants require carbon to grow. It continues from there that the more growth we have in plants, like things like trees, store a huge amount of carbon. The other thing that we have to consider in regenerative agriculture is the place that livestock holds, and livestock is very important, especially animals like cattle. The way they graze is the same way that buffalo grazed. They kind of wind their tongue around the blades of grass and yank. Sheep are not as desirable because sheep bite, and they can bite the grass right down to its roots almost. The grass, the cattle and the grass that they're grazing kind of have a bargain, because the cattle want more grass too, right? This is why buffalo moved so frequently, because they didn't ever overgraze. The buffalo and the grass had this pact: we'll eat you to this point, and then you come back. So that whole process is storing CO2 and increase. Because of that, the other way to say it is it's increasing the organic matter content of the soil. We have very little CO2. 0.04% of the atmosphere is CO2. There are studies being done in the Corn Belt, in the Midwestern states, places like Illinois, where scientists are measuring CO2 in the atmosphere, calibrating that with the rate of growth of corn, because that's what they grow the most of, corn. And there's a certain point in the growth of the corn where there is not enough CO2 to maximize growth. Crazy. I mean, it's crazy. We're just meddling. It's just another thing we're meddling with. We should stand back and look at what happens naturally. There are species of fungus that are naturally in our soil that actually they secrete glomalin, which is a sticky substance, and it makes the soil aggregate. So instead of having, this is clay, hard clay, instead of having a bunch of big clods, what I've got here is a whole bunch of little aggregates. So that those little lumps of soil are held together by a sticky sugar called glomalin. And this is an interesting way to look at it too. This is very friable, it will break apart. But there are holes, those are wormholes. They go through to the, and come out. This, like I said, it's friable. If I hit it, it'd all fall apart. So I call a soil with this kind of texture microorganism condominium, because all kinds of creatures live here. Some that we know about, some many that we do not know about. But the characteristic of what they do to the soil is they open it up into let me think, more permeable texture. So this soil holds water. When it rains, we're not having gullies of soil washing down the slope. It infiltrates into this open, porous soil. So that's one of the first issues we need. Of course, I just talking about fertilizers, but we need water, and we need to be able to hold the water that comes as rain. But that was when I started inoculating my garden seed with mycorrhizal fungus. That was the first change I saw. And that's what a farmer you have to see something happen, right? I saw it in yields, I saw it in the size of things like lettuce, I saw it in the time from planting out seedlings to harvest, that shortened. So overall looked great, and this soil texture that allows the water to be held is really critical. To get nitrogen out of the air, these bacteria, and they're all kinds of different species, not the specific ones for peas and beans. There are a lot of species that just require a particular environment. They need to be in a part of the soil root system that's slightly anaerobic, so not too much oxygen, just the right amount. They need to have food. All these microbes need to eat, so they have to have the appropriate food. So the structure that they create is called a rhizosheath, and it's basically, this is a bare root here with no soil attached to it. This root has a little bit of soil, and then when you get close to the seed, close to the growing point of this is oats. You can see there are sheaths around the oat roots, and that is where the nitrogen-fixing bacteria live, and they're fed by fungus. It's like a little farm there, taking nitrogen out of the air, making it plant available. And the fungus that makes these rhizosheaths I've never seen this kind of thing in the soil before. So it's something that's come, everything's there, right? But you have to activate it. So I think it's come from increasing the mycorrhizal fungus in the soil. And this is just another step along in where we have to get to have a healthy soil. It's the system, right? The fungi can't survive without photosynthesizing plants. The plants can't survive, really. They can't get the nutrients they need, especially phosphorus, without the fungi. So nature just has it worked out. If you leave the soil bare, it's going to be covered with weeds. soon, fast. No healthy natural system would leave bare soil. Yeah, great. So I can't do it either, but I'm not sure what I can plant. I mean, and a lot of what we produce in a vegetable garden is annuals, so I have to be able to replant next spring. So my solution is what I did in that patch there. Last night I seeded oats and peas, and it's called forage radish or eco radish. It has all kinds of funny names. It's really just daikon. It has long, deep roots, so it goes. If there's any compaction, it goes through. It opens up the soil, improves water infiltration, and when it comes up, it will stay green well past the first frosts, but it does winter kill. So in the spring, if I can get on the land early, it's not in the way of planting seedlings, annual seedlings, which is where the money is for me. And you can ignore all the trash on the surface. If you're planting seedlings, you just put them in, and the trash will, after a few weeks in the spring, will decompose. Yeah, whole new system. Makes the transition to organic look like peanuts. This is so much more important. It's important for both conventional and organic farmers to restore the fungal content of our soils. Water infiltration is a huge benefit. So drought resistance, because the water's down in the soil profile, and capillary action will bring it up. But if you let it run away, like you increasingly hear about floods in the spring, I think it's because the agricultural land is not soaking up the water. We didn't have a huge amount of rain in the spring, but there was a lot of flooding because pavement and fungi depleted agricultural soils are not letting water infiltrate, sending it down the rivers to the sea with a lot of nutrients. So, yeah, new frontier. A lot of people thinking this way. Certainly not alone. Both conventional and organic farmers. Because it starts to hit you in the face. Reduced yields, weeds, soil without good tilth, like lumpy clay and dry sand, so no good tilth, loss of organic matter because the sun, if the soil isn't covered, the sun burns it off. I don't know how the fungi are producing organic matter. They're decomposing and producing organic matter, so huge amount of carbon sequestration. CO2 goes into the soil, and carbon stays there, humus stays there. Big carbon sink. So if you're worried about global warming and CO2, there's the answer. Because I want to be healthy, and I want my community to be healthy, and we're not getting nutrient-dense food unless we have a really healthy soil microbiome. In general, farmers are working with dirt and adding synthetic fertility like nitrogen and phosphorus, and that won't go on. It can't go on. We get floods because the soil, there's no open texture like this to let the water impregnate into the the reserve and the groundwater. We're getting drought because we don't have that reserve in the soil. I don't have to irrigate here because this texture of soil holds a huge amount of water. Fungus need water to move. The hyphae are long threads and they can't move through dry soil. So they make sure there is soil moisture. It's nature's plan to keep everything in balance, and we've taken steel in the field and destroyed the natural balance. To me, regenerative implies that we humans have some ability to change things for the better, to regenerate. I prefer to think of it as restorative, because we're not inventing anything new. We're basically just we're letting Mother Nature do what Mother Nature does best. And for me, because I make my living here, and it's somewhat tenuous at times, it's really hard to let go of practices you've used that basically sustain you economically. It's hard to let go, and just it's a total mental shift to the what can I say? Basically, you have to admit that you have no control, and you have to step back and let nature do what nature does best, which is make things grow, right? There's lots of trees here, they're healthy, nobody puts any fertilizer on them. We have clean water, we have good wells. I mean, Muskoka, it's a land of lakes, we have water everywhere. Why would you need to irrigate? We have heavy dew at night. You still have to water in seedlings, but once they're established, once they have a root system in this wonderful porous soil, they don't need any water other than what comes from the rain and the water table. Glyphosate or Roundup is basically made to kill weeds and for many more things, like to dry down grain in the fall so you can harvest and put it in your bins and it's dry as a bone. It's just one of the most destructive things that could happen. I don't know, it's just not, it's an immoral action to put glyphosate anywhere because of the effects on all kinds of life, including the soil microbes. Nature abhors bare soil. So what farmers need to do when they've taken off their crop is basically immediately replant with a cover crop. Some farmers now are actually seeding their crop into a cover crop so that there is never even a few hours of bare soil. And they're getting really great results. So a cover crop is the purpose is to, first of all, armor the soil, cover bare soil. The people who are doing experiments are finding that multi-species cover crops, particularly cover crops with a multitude of families, are much more effective than what I told you is three different species. Ground that isn't bare is cool. It's cooled by the shade of the plants growing on top of it, and it's cooled by the fact that it's moist. So yes, bare ground is absolutely unacceptable from any way you look at it. Because to keep it bare, they need herbicides. Photosynthesis, I mean, it's pretty elegant. It's the energy of the sun and the process of photosynthesis, producing carbohydrate, sugars, to feed the microorganisms in the soil. And they, in turn, so root exudates from the plants feed the microorganisms. The microorganisms, in turn, make the nutrients in soil plant available. Quite an elegant, basically it's a civilization and a culture that we could emulate. So closed loop agriculture means that the farm organism, the farm ecosystem is self-sustaining in itself. That requires plants, animals, management of manure to make compost. So you're not using raw manure. The composting process kills weed seeds, kills any pathogens that are there, and it's one of my big desires to be able to make fungal compost, fungal-rich compost. That's my next summer's project. So closed loop, animals produce manure, which is fertility, feed people. People do have a place in this whole scheme because you sort of have to manage the cycles. You're limited by the amount of land you have, and you can't just let nature totally take its course. But well-managed pastures rejuvenate quickly, like we were talking about. The cattle eat the grass to the optimum point for grass regrowth and carbon sequestration. Yeah. The human being's part in all this, I guess, is to store the food so we can eat all year round. But I think what has been missing from our understanding of what's going on is knowing more about the soil microbes, maybe beyond our capacity as human beings to understand what's under the ground, what we can't see. And I think nature's taken precautions by making over 90% of the reactions that we know happen in the soil are not culturable in a lab. So we can't meddle with those processes because we don't know what they are.